Last video, we looked at how we might use key events and using JPanel and drawing in the JPanel to create a simple interactive program where we move one square and try to hit another square. That's kind of an interesting program, but we might want to actually add some movement and make things move around a bit. So we can restructure that, but first let's talk a little bit about threads. Threads in Java are just a way to have two things happening at once. Now, we've already had two things happening at once because we've shown a user interface and we've done things there, but we've also been able to handle things in the background. It might not seem like we're doing two things at the same time, but it's really kind of how things work. Once we open up that user interface, we have a second thread that's operating. But we can manage threads on our own. So I'm going to go ahead into Eclipse and I'm going to create a new Java project, and we're just going to call this simple thread demo. And I'm going to hit finish because everything is fine there. And I'm going to create a new package, timothy.r.james.thread. We'll just call it .threads, and we'll create a new class. We'll call it main. And I'm going to create a main method, public static void main. Now, within my class here, I can actually create new threads pretty easily. And a thread is just a class that extends thread. There are two different ways to do this. We can create a class that implements the runnable interface, or we can create a class that extends thread. So I'm going to create a new class. We'll call this my thread. And we'll just have this extend thread. And the thread class, we really want to concentrate on one method called run. Public void run. And this we just do something here. Public void run is just giving us an opportunity to do a thing here. So maybe what we want to do is system.out.println a system.out.println b and system.out.println c. And we can make that thread run. All we have to do is create a new my thread here. My thread is equal to new my thread, and we can start it. Thread.start, and that's going to tell Java to schedule this thread and set it up, and we're going to start running it. So if I hit run, I get ABC. Nothing too exciting here. But I could create a second thread here. My thread 2 is equal to new my thread. And then I can say thread start, thread 2 start. Now when I run this, if this was just calling the run method, then I'd get ABC, ABC. And we can see how that works. If I change this to run and run, it's going to call ABC and then ABC. And you can see here, I'll make the console a little bit bigger, ABC, ABC. And if I run this 100 times, I'm going to get ABC, ABC, ABC. Just every single time, it's just going to happen that way. So if I change this to start, what actually happens is this is telling Java, run this as a thread. So run these two things, but you don't necessarily need to run them sequentially. I'm basically taking my program and I'm splitting it into three things. There's going to be, we'll put a line down here. We'll say three things now can happen. Thread can start and call the run method in my thread. Thread 2 can start and call the run method in my thread, and done can happen. So if I hit run here, now we'll see the order that things happen is a little bit more confused. A, B, done, A, B, C, C. And it's not exactly going to be the same thing every time. So you'll notice as I call this, or as I run this over and over again, the ordering can get really weird where done is going to happen maybe before these two. And the reason why I might want to do this is I might have some work that I need to execute. I might need to do things that maybe I can do in parallel, or maybe I need to do something that's going to have to wait for other processes, so I want to do something in the meantime. So threads allow me to kind of execute things simultaneously. Now, one of the ways we can do this is through this myThread class. Another way we can do this is we can create a new class. We'll call it myRunnable class. And instead of having it extend thread, we'll just add an interface called runnable. And I'll hit finish. And the only method in runnable is run. And we'll go ahead and implement that. We'll say system out println x, system out println y, system out println z. Now in my main method, I can call thread, and I can create a thread and call start. I can create another thread and call it start. Now, to run a class that is runnable, that implements the runnable interface, I have to declare it, and I have to pass it into a new thread. So my runnable class is equal to new, we'll say runnable is equal to new my runnable class, and we'll create a new thread here, thread3 is equal to new thread, and we're going to pass in runnable. We're basically telling this thread to run this runnable thing. And then down here we can say thread3 start. Now all of these things can happen in random order. So if I hit run, we'll go ahead and save our file here. You'll see now things can get even more confused. ABC, XYZ, done ABC. So it looks like that time things ran at the same time. But this time ABC, yeah, we kind of got ABC, ABC, XYZ. So things are running a little bit more sequentially here. But if I take out maybe thread 2, and we have fewer things going on, maybe things get a little bit more mixed up. So done X, A, Y, Z, B, C, A, X, B, C, Y, Z. So you can see here, the threads are actually, they're executing, well, A, B, and C are always going to be called in sequence, and X, Y, and Z are always going to be called an output in sequence, but they may not happen one after the other. A, B, C will always be one after another. X, Y, Z will always be one after another, but X can happen in the middle or at the beginning or at the end of A, B, C. And the more we do this, the more we're going to see variability and kind of weirdness. So it's interesting how we can make this run multiple things. Now, threads aren't just used for outputting values or writing things on the screen. You might want to actually use threads to animate. So I'm going to go back into the key demo project that we worked on in our last video, and I'm going to change things around a little bit. I'm going to create a new class. I'm going to call this new class target rectangle or target area, because we might want to change that at some point. And we're going to just take everything here, and my target area is going to have a couple of methods. So if I go back into key demo panel, I've got my rectangle here as target. I want to actually move that around, and I want to be able to do things with it separate from the rest of this. So I'm going to pull this out of here, and this is going to, as you can see, it's going to cause some problems. I've got a couple of errors. We'll come back and fix those, and we're going to just create this, and we're gonna now paste that in here. And notice when I paste in Eclipse, it's going to automatically import that. I'm going to call this bounds here instead of target, and I'm going to provide access to it. Public rectangle get bounds, return bounds. And this will allow me to manage this. Now, I'm also going to move a couple of other things into this class from key demo panel. I'm going to pull in my color. We're going to encapsulate that in our target area. Private color. We'll go ahead and import that. We'll set it equal to color.blue. And we'll say private or public void set color. This color is equal to our parameter color. So now we can handle that inside of this class. And we're also going to add a draw method, public void draw graphics, and I'm going to need to import that. So I hit Control Space, graphics G, and to draw, all we have to do is g.setColor equal to our color, and then g draw rect xy width height. So we'll say bounds.x, bounds.y, bounds.width, bounds.height. And this will draw a rectangle. So now we can go back to our key demo panel and we'll fix some of these errors. We're going to use target. We're going to create a private target area. Area is equal to new target area. And we're going to not paint that here. We're just going to pass in that G. So we're going to use area.draw G. Then we move down here and we can say if target.getBounds intersects mover, or I'm sorry, if area.getBounds intersects mover, we'll go ahead and set the color. Area set color, color.black, area set color, color.blue. So now that we've done this, we can actually animate our our target area. Now, if we run this right now, this should look pretty much exactly like what it looked like before. Let's go into our main method so we can run that main method, and it's going to work kind of the same way. We changed that to a draw rect instead of a fill rect, but you can see here, you know, it's going to work the same way, and if we get up there eventually, that's going to change to black. There you go, and as we move out of it, we lose that black line. So what if we want to move that around using a thread? Well, we can use target area now, and we can call, or we can make target area implement runnable. Now, we're going to need to implement that runnable method, so we can just use run right here. And what we're going to do is, let's say we're going to have our rectangle move to the left and then move back to the right. So we'll create another Boolean variable, moving left equals true. If we are moving left, then we're just going to remove 1 from bounds. Bounds.x minus equals 1. Else, and if we're not moving left, we want to be moving right, so bounds.x plus equals 1. And we'll do some checking here, so we're going to say if bounds.x, we'll say if bounds.x gets to be less than 10, we'll switch this so we're moving right. Else, if bounds.x gets to be, we'll say if it's greater than, we started with 420 here, so if it goes higher than 420, we'll say moving left is equal to true. So this will cause our rectangle now to move to the left and move to the right and move to the left and move to the right and move to the left and move to the right. And we'll have it do this forever. So we want this to happen over and over again, so let's go ahead and say while true. Well, actually we'll say, we could use while true. If we use while true though, what we're going to end up with is an infinite loop, and we want to be able to stop that eventually. So let's go ahead and move. We can just select all that code, we can hit tab, and that will move that over. So we'll say while true and just do all of these things. Now in our main method, actually, you know, we'll do that differently. In our key demo panel, we're going to create a new thread in our constructor. New thread, we're going to pass an area, and we're just going to start this thread. Now watch what happens when we run. Well, we're not actually seeing this, but you'll notice as I move, oh, that's jumping all over the place. That's because we actually haven't called repaint. So let's go ahead back into our target area, and we'll have it repaint every cycle here. We'll have our key demo panel repaint regularly. So we have a couple of ways we could do that. We could actually just create another thread here that's causing this to repaint maybe every few seconds. That could get pretty expensive, so maybe we don't necessarily want to do that. Maybe we want to move that runnable, that movement somewhere else. Maybe we want to create a new thread. It's really kind of a question of what you need to accomplish here. So you could really make an argument to do it both ways. One thing that you'll notice as well is our program has never stopped because we have this while true, which is just going to continue forever. So let's go ahead and stop our program, and we want to do a couple of things differently. So one of the things that we might want to do differently is we might want to repaint this. So we could do that by moving our run method into key demo panel and just having it repaint regularly. We could also, you know, have this implement runnable here for simplicity. And now we need to implement a run method. And we'll just say while true this dot repaint. Now this is going to get really nasty. New thread this start. Because what you're going to see is the system's not really going to have much of a chance to do anything because it's just repainting so frequently. And this is happening so fast that we can't even really see where the rectangle is. So we don't want it to do this so fast. So fortunately, we could say, well, maybe we want to repaint every 10 milliseconds. So let's go ahead and say thread sleep 10. And that's going to, or if we want to repaint after 10 milliseconds, we can do that. We can also say, let's change this to 100, and then we'll sleep for 100. So we should do this about 10 times per second. Now we'll throw an exception from this method, so we have to handle that, but we shouldn't have to worry too much about an interrupted exception at this point. we'll just print that out and we'll ignore it for now. So let's go ahead and stop our program and we will run. Now our repaint is happening less fast, but our rectangle is still moving as fast as it possibly can. So we want to change that too. So let's stop our program and we'll go back into our target area and we'll tell this now to give it a wait too. And we'll have this sleep for 100 milliseconds and we'll do the same thing. Try, catch, interrupted exception, IEXC. Now when we run, we'll get much smoother, slower movement. And you could change things around. You could have your rectangle move more than 1 pixel at a time. You could have your rectangle sleep for less, but we can move this around, and you want to experiment till you see what kind of looks right. But we can move this up now, and you can see eventually we're going to hit that rectangle. There we go, rectangle's black. Now one thing you'll notice is that when we just sit here, we're not ever checking for intersection again, because we're checking for intersection when our rectangle moves. So as long as that moves, it's going to stay black, but if that rectangle moves away from us, it's still going to stay black until we hit that key again. So this will work mostly, but we're also still getting this stop. So there's two ways to fix this. There's a complicated way where we add a window listener and we wait for this to exit, or we can just change this so that instead of dispose on close, we exit on close. Now exit on close is generally not always the best way to do things because it's going to just tell the whole system when I hit close, shut everything down. But for now that will work before we get into more complicated threads. We might want to do a little bit more where maybe we organize our threads, and in a later video we'll set up some things that will be a little bit more effective for the way we're managing our threads. But for now this should do it. This should give you a general idea of how threads work and how you can start them off, and give you an idea of how you can add them to animate things in your program. Thanks for watching, and don't forget to practice your coding.